Yeah, hi, grade 9. So this is going to be video 3. We're going to talk about solving inequalities. For now, we've been just content to talk about the language, more than, less than, shall not exceed, all that translation we've been doing. I've showed you how to graph them on a number line, how to express them symbolically with the symbols, again, how to graph them on a number line. Now it's actually time to get into actual solving, okay? And as my title kind of hinted at here, solving inequalities is no different from the work you've been doing from the last 2 months in terms of solving equations, except for one special rule. And I'll definitely show you what that rule is, obviously. But let's just show you, I'm going to give you a couple examples where they're similar. So let's say you have, and let's just use really, really easy to follow examples, okay? Let's start with this one. Let's use orange. Okay. So let's say you have n, whoops, got to switch to my pen, pardon me. Okay. Let's say you have n plus 4 is equal to 20. Okay? So you know what to do. You're supposed to subtract both sides from 4, n is equal to 16. All right? Now, in the inequality version, let's say you had n plus 4, and it doesn't matter which inequality sign that you have. So let's just pick less than or equals to, okay? Now to get the variable by itself, same steps, right? You're still going to subtract 4 from both sides. All right, so that goes away, looks like it did over there. And n is less than or equal to 16. So I guess what I want to point out is they're extremely similar to the point of like same steps, right? Same steps. All right, let's look at another one, okay? Let's say you had, maybe purple would be a little bit better. So let's say you had negative, no, let's not do negative because that's part of the special rule. Let's do 4x is, let's say, subtract 6 is equal to, let's make this 4, okay? All right, so let's add 6 to both sides. All right, just like we normally do, there goes away. 4x is now equal to 10, all right? And now we're going to divide both sides by 4. And we're going to divide both sides by 4. And we get x is equal to 2.5, okay? You can check me on that, but I just know that $10 split between 4 people is $2.50. Now over here, just to do it quick, let's just do a simple greater than equation. There's no difference. There's going to be no difference, okay? So you get 4x is greater than 10. Let's do greater than, please. All right, greater than 10. Divide both sides by 4. Divide both sides by 4. And you get x is greater than 2.5. Okay, so again, same procedure, okay? So far nothing has changed, okay? Let's do just one more simple subtraction. So let's do m minus 2.5 is equal to, say, 5. All right. So you're going to add 2.5 to both sides. All right. 2.5 to both sides. And that makes that go away. And m is equal to 7.5. All right. I'm going to assume that you know how to deal with your fractions, or maybe you converted this to a decimal and called it 2.5, then converted it back, whatever. We're definitely well past the point of you should be able to solve this at the end of grade 9, okay? This should be, if I was a grade 10 math teacher next year, that's a no-brainer. Same thing over here, okay? And trust me, I'll change it up for the next one. But if this was, doesn't matter, greater than or equal to 5, same procedure, right? You're going to get rid of your constant first. All right. Whoops, I don't really need that symbol. Let me just add the 2.5 to both sides. Okay, that goes away. And m is equal to, let's get a real m here, Mr. Smith. M is greater than or equal to 7.5. So I've just given you 3 examples. It doesn't matter how big or small the numbers are. Yes, I used easy examples, but I could have made it super complicated. Okay, so now I'll show you the exception. But to show you the exception, I'm just going to start with a blank page first and prove to you why the exception exists. Okay, so let's say you had this. Okay, let's go with just a mathematical truth. All right, so let's say you have 4 is equal to 4. Okay, so far so good. Little happy face. What if you were to multiply both sides by -1? And remember, we were allowed to do with whatever we want. So let's go ahead and do that. Let's go 4, and we're going to multiply this by -1. Okay? And we're going to multiply this by -1. Okay, so what's the result? We get -4 is equal to -4. Now this is still true, and so we're still happy. All right? We started with a true statement, right? We did something to it, right? We multiplied by -1, and we still ended up with a true statement, okay? Now, I'm showing you this for a good reason, all right? Just bear with me for a sec here. Didn't like the way that true turned out. This is true. Okay. Now, I know some of you might want to ask, why did you multiply by -1? Just for kicks and giggles, just to prove to you that I could do whatever I want, right? Whatever you do to one side, you do to the other. Equality is the left side. Does the left side equal the right side? Is this thing balanced and true? And I did nothing wrong here. I did nothing illegal. I'm allowed to do this, okay? I am allowed to do this. Okay, now, what happens on an inequality, though? Okay? All right, let me just switch color. Let's now deal with an inequality, okay? So in this case, let's say you had this, okay? Let's start with a truthful statement. 3 is less than 7, right? Okay, so that's good. That's true. No problem. We have a happy face, okay? Now, what if we did the same thing we did to this side? In other words, what if we wanted to multiply both sides by -1? I'm still following the rules of algebra and problem solving. In other words, whatever you do to one side, you do to the other to maintain balance. But something really kind of interesting happens here with an inequality, okay? So what's the result here? Whatever I did to one side, I did to the other. I followed that rule. That rule's, totally legit. I'm not breaking anything here. But now we get this answer of -3 is less than -7. Wait. What? That's not true. This is not true anymore. That's the key part of it. This is not true anymore. Okay? So what does that mean then? It means you need to invoke the special rule. Okay? And the special rule says something like this. I'm just going to put in a new page. Okay? And I'll type it out. I'll type it out live here. Okay. When multiplying or dividing, because listen to me, dividing is nothing but inverse multiplication. Like from dead maths, they go hand in hand, just like addition and subtraction. Addition and subtraction are two sides of the same coin. Multiplication and division are the same, two sides of the same coin, right? Timesing by 1/4 is the same as dividing by 4, right? Dividing by 2 is the same as timesing by 1/2. So obviously, by logic and mathematical rules, this special rule would apply to both multiplying and dividing. When multiplying or dividing both sides of an inequality by a negative number, you must reverse the direction of the inequality. To maintain truth. Okay? You must reverse the direction of the inequality to maintain truth. Okay, I'm going to go back to my pen. So, here's a series of examples. Okay. So I start out with something just as simple as, you know what, 3 is less than 10. All right. Well, if I were to multiply both sides by -1, right? If I were to multiply both sides by -1, then I've got to flip this sign, okay? I've got to flip the sign. It's got to now face the other direction, because what am I looking at here? I've got -1 times 3. We start off with a positive quality on the left side. The left side was fundamentally positive in nature. The right side was positive in nature. And there's a relationship here that's not based on equality, but in balance. One quantity is less than the other, or one quantity is greater than the other. So to maintain the truth, right? It's the truth that counts. It's not the direction of the sign. You've got to maintain the truth. So -3 is now greater than -10. This is true and we're happy, and this is true and we're happy. Okay? So I know some of you will be very skeptical of that at the outset, at the beginning, because you're like, wait, are you just allowed to reverse the sign? Yes, because you did something to the equation that alters the fundamental relationship of that equation. The 3 is less than 10. The 3 is subservient to the 10, right? Would you rather have 10 or $3, right? Well, you'd rather have $10. But over here, think of it this way. Would you rather be $3 in debt? Or would you rather be $10 in debt? -3 is greater than -10 when you multiply or divide both sides, okay? By the way, here's the same example with division. The exact same example with division, just so you will believe me. So 3 is less than 10. Now, what if I were to say 3 divided by a -1 is less than 10 divided by a -1? Well, that's not going to be true, because 3 divided by 1 is 3. Positive 3 divided by -1 is -3. Less than, and this would be -10? No, that's not true. That's not true. It has to be -3 is greater than -10. Okay? Let's just do one more example on the fly here. All right? Let's go straight out red. Okay. Let's start with the one that has the greater than sign. So let's go with 16, okay, is greater than 5. All right. So what if you multiply both sides by -1? All right. And I'm saying -1 because the multiplying is easy. But it's any number, okay? I just want to emphasize it's any number, -1. All right. So -1 times 16 is -16. So now we have to flip the sign to make sure this is true. 5 times -1 is -5. And this is true. This is true. Without flipping the sign, it would not be true. Okay? It would not be true. It started out as true. It must end in truth. You can't start with truth and end in falsehood. You can't start with truth and end in a lie. So if there's an adjustment to be made, then you make the adjustment in math. It's as simple as that. Okay? So let's see how this looks. Let's say you have -4x is equal to, let's just make it easy, 20. So what do? You divide both sides by -4. Okay, so divide both sides by -4. So we're back to just going back to our regular solving. X is equal to -5. Okay? That's true. Now, what happens here? -4x. All right? Let's say it's supposed to be less than 20. Okay? All right. Well, then you divide both sides by -4. Divide both sides by -4. And what you're left with is x now must be, just trying to switch the color here. Now it has to be greater than, you had to switch the sign to -5. Okay? X has to be greater than -5. All right, so here's your number line. Oh my gosh. Let's try this with a ruler, Mr. Smith. Okay, so let's actually just plot this out for a minute and talk about it. So here you go. There's your number line. Let's put -5 in the middle. Okay, so that's -6. That's -7. Let's just make this -8. It's fine. It's good the way it is. -4, -3, Okay, let's make that negative 2. Now, what we're saying is x cannot include, remember, it's not equals or equals to, and it has to be greater than. Yeah, this is true, right? You just start testing this in. If we hadn't reversed the sign, if we'd said x has got to be less than negative 5, that means negative 6 would work. Well, what happens when you put in negative 6? Is negative 6 times, and this is supposed to be less than 20. Negative 4 times negative 6 is 24. Is 24 less than 20? No, it's not. Okay? So reversing the sign actually maintains the truth. Let's test a value over here, okay? Let's use negative 3. What if we were saying x is equal to negative 3 in this solution? Well, go back to the original inequality. Let me just use a different color. If you said x is equal to negative 3, well, now we could substitute a negative 3 for the x and say, is that less than 20? Well, yeah. Negative 4 times negative 3 is a positive 12. 12 is less than 20. It works. So even though you seem a little skeptical of it, you're like, wait, we do flip the sign when we multiply or divide by a negative number? The answer is yes. Trust me, when you plot this out, it really, and you test, you guess and test, you substitute in and test, this will work. Okay, let's do maybe 2 more and then we'll call it quits for this video. All right, let's do this one. All right, so your normal equation. Let's do a division one, okay? So let's go m over negative 2 is equal to, let's go with negative 14. Okay, so what are we supposed to do to both sides? If it's m divided by negative 2, why don't we multiply both sides by negative 2? Okay, so whatever you do to one side, do to the other. All right, so this would reduce to just an m, and this is supposed to equal positive 28. Now, some of you, by the way, just a quick little thing, some of you might have said, hey, Mr. Smith, can I cross multiply? And the answer is yes, you could cross multiply. Here's the inequality version. Let's say it's m is over negative 2, and it's supposed to be less than. Whatever the m value is supposed to be, when you divide it by negative 2, it's supposed to work out to be less than negative 14. So whatever this is, you better get like a negative 14.1 or a negative 15, a negative 16, a negative 17.5. You better get something smaller or colder, to use the temperature analogy, than negative 14. Okay, so this case we're going to do what? Again, the procedure is the same, guys. You still multiply both sides by a negative 2, right? We're going to multiply both sides by a negative 2. But in doing so, as soon as we multiply or divide both sides, this has to flip. It has to flip. All right? And of course, this is negative 14. So this gets to be m, and this, of course, is going to be the same answer numerically. It's just that the sign has to flip. Okay? The sign has to flip. So we've gone from here to here, right? So this went from less to greater. It has to. Okay? All right. So, and again, if you did and you can always test this on a number line, right? So here's your number line. Mark it off like so. There's your 28. There's 29. There's 30. And there's 31. Whoops. What am I saying? 27, 26. All right, well, let's just pick even values because we're dividing by 2. Let's say if x were equal to 30 and x were equal to 20, or m equal to 30, m equal to 26. Well, if m was equal to 26, you'd have 26 divided by 2 is supposed to be less than negative 14. 26 divided by negative 2. See, that isn't true. That's not true. No. So your boundary point is supposed to start at, I got a little ahead of myself. I forgot to really graph this. It's supposed to be greater than, no shaded, this is open, right? This means open. Don't close that hole. All the values greater than 28 should work in this question. So now let's try 30. If m were to equal 30 and you divided it by 2, and it's supposed to be less, you go back to the original question with the original sign. Maybe I didn't make that clear. You may need to reverse it in solving the question, but when you go back and substitute in, you keep the original version of the question. Just thought I'd make that clear. Negative 15 is less than negative 14, and that is true. That is true. Okay, I'm going to leave it there. That's enough examples for now. You're just going to have to get used to it. The bottom line is this. Multiplying or dividing an inequality equation. If you're multiplying and dividing by a negative number, switch the direction of the inequality. Okay? And it doesn't matter if the or equals to part is in there. The less than has to become the greater than. If it starts out greater than, it has to become the less than. Then you can plot your solution. Okay? Multiplying or dividing by a negative number reverses the direction of the inequality. Okay? I hope that helped, grade 9s. We'll see you in video number 4. Yeah. All right. Talk to you.